So we're at 9 a.m. So let's begin. Please give me a thumbs up if you can hear me. That would be appreciated. Awesome. Thank you. Good morning from the Netherlands. Unfortunately, I'm not with you today. I would have liked to be, but circumstances. So thanks for coming out so early, 9 o'clock to my talk. So I'm going to talk about Kubernetes today, and why it isn't the answer. And so in this talk, we'll find out why it isn't the answer, but more importantly, we'll discuss what the question is, and we'll discover what the question is hopefully at the end of my talk. So a couple of things: we have the Slido. If you want to ask questions, we have a mic at the end. So please hold your questions because being doing an interactive talk remotely like this is kind of difficult. So write them down, and we'll get to them at the end. We have plenty of time. I expect my talk to be around 30 to 40 minutes, so we have some time to discuss after. So let's start with me. I am Joep Piscaer. I'm from the Netherlands. It's raining outside quite heavily right now. So there's that. Find me on Twitter at jpiscaer. Um, and I do a couple of things. I do industry analysis. I'm an analyst, which means I look at solutions and have opinions about them. I do developer relations, tech marketing, which means I like community. I like talking about technology in communities. I like building communities, which is what I do for a number of companies, including some well-known startups. I work for a small company, my own company called TLA Tech, and you may wonder what the TLA stands for, but don't worry about it. It's just a three-letter acronym. So let's begin. Why are we here? I mean, it's Thursday. It's 9 a.m. It's early. I bet you had a lot of fun last night in all kinds of parties and dinners. So let's discuss why we are here, because everyone is talking about Kubernetes, right? The technology, and everyone's talking about its potential, but no one's really talking about the consequences of making the choice for Kubernetes, or maybe evaluating something else. And to kind of clarify the problem, this self-operating napkin is the way I see Kubernetes. It does solve a problem. We're just not sure which problem it actually solves, right? And it becomes difficult because Kubernetes is so many things to so many people that it kind of becomes unclear what problem we're actually solving. And it's not just me saying this. Even Gartner says it. Um, Not that I take Gartner too seriously all the time, but in this case, it kind of came in handy because they say Kubernetes isn't always the answer. But they forgot to mention as well what the question was again. So we're not really any step in the right direction because even Gartner doesn't know. And so my point of this whole talk is I think we collectively, everyone in the IT industry, may be making technology decisions the wrong way. And in this talk, I'm going to help you figure out, okay, what's the questions I got to ask myself to do it the right way, right? Um, and so note that I'm not saying Kubernetes is the wrong choice. Absolutely not. There's plenty of use cases where Kubernetes makes sense. I'm just saying that the way we come to the conclusion, hey, we have to use Kubernetes, or hey, we have to use something else, the way we make those decisions is too technology focused. We are not taking into account a lot of other things. And we all know Kubernetes has a lot of potential, right? That's why everyone loves talking about it, using it. First and foremost, it does something that I haven't seen any other technology do, which is democratizing infrastructure for developers, allowing them to deploy applications more easily, um, and especially more self-service. They're not dependent on anyone else to deploy their applications. And so over the years, an ecosystem has grown around Kubernetes, solving for things like monitoring, or networking, or storage, or a registry, or look at the picture, right? There's many examples in there. And so again, the ecosystem is large. It does a bunch of things. My point is, we shouldn't necessarily look at that because even though there's lots of potential, we have to do something with that potential. We have to be able to do something with that potential. And so my point is, don't look at the potential necessarily. Don't let that guide you, because potential is not real. It is unrealized success, hope. And hope, I think, is postponed disappointment in a lot of cases. And again, I'm not saying that's necessarily the case for Kubernetes, but if you make decisions in not the right way, the chances of hope being postponed disappointments is pretty big. And especially because overcomplicating things when you don't need to, that becomes a burden. That becomes, technical debt. That becomes organizational friction. Um, and so you have to make the right choices to solve your problem right now and then looking into the future. But how do we know if we're successful with something, right? The problem is if we don't know what we're actually solving for, what problem we're trying to solve, how do we know if we're successful? And so if we don't know what we're solving for, we end up adopting technology for technology's sake, right? Kubernetes can solve many problems, but did we solve the right one? That's kind of the mindset. And so this animation kind of sums it up. The falling person is Kubernetes, if it starts moving at some point. There we go. So the falling person is Kubernetes, the leaves are the organization, and look how long it takes the organization to start moving, right? And how chaotically it moves. And so this is kind of a nice analogy for you can do so much with a piece of technology, but you need to be able to adopt it successfully first, which requires many things changing, like changing the way you organize your teams, change the way they deploy an application, change the way you use infrastructure. And so you have to change your organization in so many ways. It's just not realistic to expect all of those changes at once, right? You cannot change the organizational structure, the way people work, team responsibilities, team dynamics, the skills that people have, the experience that people bring. And that's just another way of saying organizations have natural inertia. They don't want to change. But in addition, once organizations do start to change, you'll notice that everything you change causes friction. Like every little thing you do, every change that you make, the organization will introduce friction somewhere, right? And it's often in unexpected places. So you need to minimize the amount of simultaneous change, and that means taking small steps, being successful in each little step, and then each little step kind of adds up to be successful in the long run. And so the question is, why are we doing Kubernetes, right? We're not doing Kubernetes because it has a lot of potential. We're doing Kubernetes because it solves a business problem in the simplest and easiest way so that we can be successful with that, little problem. And so, in other words, we have to overcome the friction of the organization to be able to adopt new technology, right? And so we can then decide if a piece of technology is worth the friction that we need to overcome. So, in other words, if you need to do a lot of work because the technology you're introducing is very complex, maybe it's not worth doing all the work if the problem that you're solving is fairly small, right? So I wouldn't necessarily introduce Kubernetes if you are running 3 containers in production. The amount of work you have to do for a successful Kubernetes production doesn't weigh up to the benefit it has if your business problem is very small. Or if you're a small software startup, you're building your own SaaS product with you and a friend, maybe not run Kubernetes in production, but think about other ways of solving your problem, right? And that's all to say that a key part of overcoming that friction is reducing complexity, because complexity is what causes all that friction. And friction, again, kills your chances of being successful with the technology. And so that also means that you have to look at, okay, what can a team successfully adopt over a given period? Because teams don't necessarily need all of those, functionality, all of that complexity at once. Maybe they just need to be able to autoscale. Or maybe they just need to be able to deploy containers in a self-service way, right? Those are small actual problems that you're solving. Instead of saying, hey, we're going to do Kubernetes and then, you get 1,000 features. Because look at this Swiss Army knife, right? Who needs all these features and who needs them all at once and even at all? So keep it simple, case. The right choice is almost always the technology that is the simplest and easiest to implement while still solving the business problem. And that piece of technology can be a lot of things, right? So instead of Kubernetes, maybe you decide, okay, a serverless architecture is better because my team is fairly small and I can't handle the complexity of Kubernetes. Or maybe you have an adjacent problem where you don't need to just run containers, but you want to run a batch job as well. Kubernetes may not be the fit for you. Maybe look at Nomad. Maybe you don't want to run Kubernetes yourself, but you want to use a managed service, which I think is a good idea anyway. Or maybe you don't want to do Kubernetes by itself because, if you're going to do Kubernetes, you have to do so many other things for observability, for a service mesh, for networking, for storage, et cetera, et cetera. Right? So it becomes quickly very complex. So again, I'm not arguing for or against any of the solutions I just mentioned. I'm just saying don't just do Kubernetes because Kubernetes. I'm saying look at the business problem, look at the amount of complexity you can handle as an organization and as a team, and kind of work backwards from that. Put differently, the organization's incapacity to change is the bottleneck, not the technology. Right? So I'm saying that if you minimize the complexity that causes that organizational friction, you have a much higher chance of being successful because you take the limits of what you can handle as an org into account. And that begs the question, okay, so what do we know now? What questions do we need to ask ourselves to figure out, okay, what solution is right for us? And so if there's one thing I want you to take home after this talk, is that you're almost always solving for some kind of organizational limitation alongside the introduction of a new technology. So put differently, if you're going to do a new technology, you have to solve for some organizational issue, some organizational bottleneck limitation at the same time. So successful adoptions of new technology rarely focus on new technology. They focus on solving some kind of organizational issue as well. And so we kind of need a minimalist approach to technology. And it always pains me a little to say this because I love technology. I used to be an engineer. I love to build data centers with all of the features and bells and whistles and super awesome and build the whole thing. But you always have to be mindful of, okay, what am I actually solving for? What business problem, what team problem, what technical problem am I solving? And how can I do that with the least amount of change from a technology perspective? And so for Kubernetes, I always like this diagram. It gives a good overview of what the complexity is of Kubernetes and what you can do with it. And so for Kubernetes, it could mean, you start out with the basics. You do a basic a Kubernetes cluster. You do one cluster instead of, a dozen, and you just focus on the deployment part. So service discovery, some networking, routing, load balancing, and kind of that's it, right? So you do the core and the controller part in this image. But maybe you don't focus on, I don't know, on Helm just yet, or you don't do very complex CI/CD processes around it. Maybe you don't do observability yet, but you do introduce autoscaling if that is what you need. And so figure out, okay, what technology piece of Kubernetes specifically is useful for me for solving my problem right now. And that's where kind of the organizational piece always comes in. And yes, I know, I mean, like I said, I'm a technologist at heart, right? I love working with technology. I love solving problems with it. And I know solving organizational problems is so much harder than introducing just a new technology, right? I mean, that's why I'm giving this talk, right? That's why I'm talking to you, talking about, okay, don't do just the technology part, but do the business part. Or put differently, don't try to solve organizational problems with technology solutions. And so this is a mantra I used a lot in a previous company I worked at, where the organization was kind of clunky, a lot of inexperienced people, so there was a lot of politics, a lot of organizational issues, a lot of management overhead, and we used to say this to each other, hey, let's not introduce a new technology before we solve the organizational issue. And that has learned me a lot because it learned me that solve organizational issues is kind of the thing. And secondary to that, you introduce technology solutions here and there, right? And that is, in my view, what technology choices are all about, and doing them the right way. It's awareness of the organizational limits, the organizational issues, and choosing the right amount of technology and the right solution to match those limitations. So let's go into what the organizational issues can be. Like, let's dive into some examples. So I always like using this image, and it's kind of meant to make fun of these six companies, but there's truth in the message behind this. Like, every organization is different, um, but also every organization, its output, the thing they deliver, is going to mimic the organizational chart, right? And in a lot of cases, when you introduce a new technology like Kubernetes, it will end up being implemented along the lines of the organization. So, for instance, each team gets a cluster, or each team gets a namespace, or this department doesn't talk to that department, and so what ends up happening is they have two different implementations of the same technology. And so, being aware of the organizational structure and kind of the politics, and the stakeholders behind it, will help you define, okay, this is where, this is our little scope where we're going to do Kubernetes first, and then we move up or we move to the side to start helping other teams as well. Another sign of organizational issues, or another cause of organizational issues, is outsourcing. Well, I'm not directly opposed to outsourcing. It can help in a lot of cases. The fact that you have kind of a contract in between you and the outsourcing teams will, they will all stand in the way of making those technology choices the right way, just because there's a lot involved, right? The contracts, the financials, the, I don't know, project management. There's different interests. The outsourcer wants to make money, while the company just wants a solution for their problem. And so outsourcing can be something that stands in the way, and maybe something that you need to solve before you can be successful with a technology like Kubernetes. And so why I mentioned this specifically is because a lot of companies outsource their IT to an outsourcing company, which means that suddenly when you start to introduce Kubernetes, you're kind of pulling back the technology and the responsibility from the outsourcing company back into your own company, which causes friction because the outsourcing company doesn't want to let go of that responsibility because that's how they make money. Um, so it's be mindful of the fact that outsourcing can be a problem, and that it is something that you may need to take into account, solve bits and pieces of that outsourcing contract, so that you can be successful with new technology. And I've seen a lot of Kubernetes projects fail specifically because of outsourcing and the contracts involved. Another one, similarly, traditional non-cross-functional teams, or silos, using tickets, queuing systems to get things done, right? So I need something of that team. I'm going to create a ticket. I have to wait, I don't know, 6 weeks, or maybe 2 months if someone gets sick, or you never know what the status is because no one updates the ticket. Ticketing systems as a communication method do not work. And so, no matter how much technology you throw at it, and how Kubernetes can help you be self-service, etc., if someone needs to create a ticket to be able to deploy something on Kubernetes, the advantages of Kubernetes are kind of undone, right? So being able to introduce new technology doesn't mean the organization is already ready for it. So maybe just not introduce Kubernetes just yet, but work on removing those silos and those ticketing systems in between teams before you start doing new technology. Handovers is one of those things that I see happening a lot. So if you have a lot of handovers of work within a team or maybe across teams, you won't be able to release quickly and often. So regardless of how much Kubernetes you throw at it, If you have a lot of handovers, maybe solve that issue first. But the problem, of course, is there's so many that you need to, so much that you need to do to solve, handover problems like this. Maybe you need to change the team structure. Maybe you need to, create multidisciplinary teams where multiple roles with different strengths and different sets of skills are put in a team. That's not something you do overnight. Maybe you need to really change your organizational structure for that. Um, and so a lot of these things are quite fundamental in a sense, that the organization needs to change fundamentally to be able to be successful with new technology, which is not something I think everyone wants to hear. Um, but it is reality. Like if you want to be successful with cloud native technologies, if you want to release quickly and often, sometimes you need to change the organizational structure. That's part of it. So the other thing that I see happening a lot is, so if we take a step back, if we look at, okay, inefficient team structures, silos, lots of handovers, what that all means is you have a lot of dependencies between teams. And dependencies between teams is the perfect way to make your entire organization grind to a halt. So if you want to have, if you want to have very busy people doing a lot of work but not actually delivering much, create dependencies between teams. And often these dependencies have historical instead of actually good reasons to exist, right? For organizing that way. And again, you have to break down these dependencies, these paradigms before you can really reap the benefits of technologies like Kubernetes. Um, Again, you may solve these things before you start to be successful with Kubernetes. Responsibility, of course, is another one. Similarly to these dependencies and these handovers, if teams share a responsibility, blurring the lines who's actually responsible for what, that is going to kill your ability to do any innovation with technology quickly. Um, so one of the things you may need to do is, create very strict, very clear matrices of responsibility. So exclusive or end-to-end or sole responsibility, whatever you want to call it, is going to be needed to fix these kinds of situations. Again, not easy. Comes down to fundamentally how do you organize your organization? How do you create teams? Um, and that's again not something that you solve for very quickly. Lastly, lots of stakeholders. If you have 20 stakeholders in a project, they all want to go a different way. That's also a great way of diminishing the success you have with a new technology, because they all want to go a different way. They all go a different way, and you end up building this monster of a technology platform that does everything but nothing well. It also creates approval gates and long change control processes because everyone needs to have their say before signing off. So those are all organizational issues that you need to take into account. And then a strange one, because this one is not entirely organizational, but if you still have very inflexible compute environments, like, and I'm not saying on-prem, because there's a good use case for on-prem data centers. But if that's really old, very legacy, very ticketing driven, not very self-service, all of that kind of indicates you're somewhere behind the IT adoption curve of new technology, which means you probably shouldn't seek out new technology just yet, and first make other improvements before you go the Kubernetes route. DIY technology is one of those very hallmark symptoms of being kind of outdated in terms of what you can handle as an organization. Um, and so what I've seen a lot of companies do is, they have on-prem, they may have some presence in cloud, and then they realize, hey, we got to do Kubernetes, and then they go and build their own stack from scratch. So they create a VM somewhere, install an operating system, install Kubernetes, and before you know it, they've created this snowflake of a Kubernetes platform that they have to maintain and improve themselves, which is, it can work. I'm not saying it won't work, but for a lot of organizations, it just doesn't, because they're not in the business of selling Kubernetes as a service or selling Kubernetes as a product, as a distribution. So for a lot of companies that go this DIY route, it absolutely doesn't make sense. I mean, why the heck are you DIYing the platform? What's the benefit? Often it's just because of historical reasons, because that's what engineers do. Um, but it's also often a sign of unhealthy management, making the wrong, setting the wrong priorities. Because it's not what the business wants, but they have allowed it. And at some point, you're in this mess. It doesn't help. Maybe solve for this problem before going that route. And now we get into a couple of smaller ones, which I'm going to go through fairly quickly. But lead time and cycle time, which I'll show next, is if they are very long, it indicates work is going from system to system or from team to team, and these indicate your teams cannot effectively pick up work, execute it, do the work, and call it done. And that can be because of handovers, like we saw, or dependencies, or inefficient team structures like silos. Low degree of automation is a common cause, and it's kind of hard to tell what the cause is, but it's definitely worth looking into lead time and cycle time. With both, both are an indication of how long work takes from starting, right, ready to start. A piece of work is ready for someone to pick up, and when it's done. Um, and again, like I said, it's worth diving into, looking at, okay, why does this take so long? Why does this team, take 3 weeks to do something that only should take 15 minutes? And I'm, extreme example, but it's worth diving into, because if teams are too busy, if they have a lot of work in progress, then there's quality issues. There's a lot of manual work, probably a lot of rework, so work that needs to be redone because of defects, quality issues, whatever. So lots of work in progress is an indication of bad automation, or just toil in general, people busy with things that aren't really important, which can be caused by a number of different reasons. Bad technology choices is definitely one, um, which is it's also a way of saying, maybe don't make technology choices too quickly, because you'll end up making the wrong one. So better think about your technology choice before you make it, right? And that prevents rework, that prevents having to redo the whole thing. Right. So we've talked about a couple of common causes of organizational issues, of organizational friction. The solution to all this, like I said a couple of times, isn't easy. It's not even a single thing you need to do. It's a lot of things. What I do know is there's no amount of technology that'll fix any of this, right? So don't introduce a new piece of technology as fundamental as Kubernetes if you don't at least partly solve these and other organizational challenges. Focus on solving those challenges. Introduce new technology where you have to, but don't think you can just introduce new technology and then everything will be fine. You have to be mindful of the organizational part. One very big way that technology can help, though, in solving these issues is by creating on-demand self-service consumption of services, of cloud, of infrastructure, of whatever, right? So the vending machine model will help to solve a lot of these issues, because a vending machine model automation will be a hallmark. So you will automate, you will create, um, you will solve for those dependencies on the background, you will solve for those handovers, you will kind of diminish the problems caused by organizational silos. So if you are in a position to create services that your internal user or external users can consume themselves, you will solve for so much of the organizational friction, right? Just being able to deploy something without creating a ticket, without being dependent on another team, etc. That'll help solve so much things. That's coincidentally why cloud has been so successful. It's not because they did anything in a technology sense very differently than the on-prem data centers. except for creating self-service services that people could consume with a credit card. So that cloud is a prime example of this model working, because instead of having to go to the purchasing department to ask for budget of, I don't know, 500 euros a month to go and consume something in the data center, you could just use your credit card. That solves for an organizational problem. Instead of having to go through an approval gate to request a new virtual machine, you can just go into a self-service portal and create the VM from scratch yourself. So the vending machine model is, and especially the self-service on-demand aspect of it, is crucial for any technology decision you make going forward. Um, and these can be anything. Like these can be um, requesting a new VM, requesting a new application on Kubernetes, requesting a new deployment, requesting a new user when you're onboarding a new coworker to your team. It can be setting up a cloud tenant. It can be setting up a backup policy for some stateful data set. It can be requesting a new database. It can be whatever. Like this is not even Kubernetes related in the slightest. Um, and so self-service is the best thing you can do for your organization. And of course, you need technology to make this work, right? You need to have an automation platform. You need to have an infrastructure platform. And so chances are Kubernetes is going to play a part of this. And this may be a business driver of why you need Kubernetes. But Kubernetes is not a given in this context. You can use any number of technologies to make this happen. That's my point. Right. So another way of figuring out what organizational problems you have is doing value stream mappings. It's a term coming from the lean methodologies. And so a VSM, a value stream mapping, is a way to visualize work flowing through the system. So I hope you can see these post-its on the screen a little, but I'll go through the kind of the structure of it. And so basically what you do is you map out the entire process from left to right, and then from top to bottom, every individual single step is drawn on one of those green post-its. And so what this will do is it gives you a complete overview of a process across teams, across departments, across anything. Just this is a business process. And so the example here is deploying a new feature from ideation into production, right? So it has a lot of steps in between. And once you have that overview, you can start to figure out, okay, this is how long each step takes. This is how long each individual task takes. There's a lot of waiting time between this and that step, or maybe you're doing a lot of work that you need to do, but doesn't actually bring value to the thing that you're doing, right? So maybe you need to document a lot of information for some kind of approval, but the approval doesn't actually have any business value, but you still have to do it, right? So that's waste. And so a VSM will help you get insights into, okay, these are steps that we actually need to do. These bring value. These do not bring value. These are waste. And so you can then start to remove the waste, automate where you can, and just create a much more efficient workflow. And you can then also map which technology is useful or which technology you're already using in each of these steps to kind of draw out the architectural diagram of the technology landscape that you're using, again, to fix inefficiencies, to fix inefficient technology choices, or to optimize for those. It goes a little too deep to dive into this in this talk. But if you're interested, ping me afterwards, and I'll be happy to explain more how this works and what the benefits are. But the goal and kind of the advantage of doing it this way is, instead of doing one big project where everything improves into a perfect state at once, because that's how a lot of projects are structured, right? You start somewhere, you end somewhere. There's a straight line, and it's called success. But in reality, the second image, the middle image on the screen, is you start doing it, you realize, oh, this is really complex, and then you panic, you abort, you have to readjust, your project fails, you have to retry, etc. And so my point is, instead of doing it in a big bang fashion, why not do a lot of these little waves, little curves where you improve one thing, you adjust to learning that new thing, which is always difficult, and then the upward trend starts to become visible, right? So you kind of learn how to continuously improve, and then it becomes easier to adopt new technology in little steps as you are, making those small steps of improvement. Differently put, you reduce the risk in each step. Um, you go from one big improvement to many small improvements, and that kind of helps you to, instead of following some ideological technology pipe dream like Kubernetes will solve everything, into but wait, if we use the auto scaling part of Kubernetes, we can solve this actual little problem that we have, and then we're successful with solving that little problem, and it'll help you make better adjustments, better improvements over time. And that's all to say, you can improve rework, or you can prevent it. Is my point? Because rework is kind of a hidden problem that will only become visible long after you've done the improvement. Right. So every little thing you do will improve, will introduce rework at some point. The question is, can you prevent it, or can you beforehand kind of see which rework is going to be introduced? Um, Another way of saying, technological debt, right? Technology debt. Because if you make the wrong decision, you will create future problems that you need to solve. Right? So being able to prevent those future problems will make you more efficient in the long run. Because that'll free up engineers. Instead of them fixing problems in 3 months, they will be able to take on new projects in 3 months. That's kind of the mindset, preventing problems instead of letting them be introduced. And technology debt is an interesting one, or technical debt is an interesting one in that respect, because it's not about preventing it entirely, because that's super inefficient. That's perfectionism. Um, but not being mindful of technical debt will, again, will create problems down the road. So technical debt, for those that don't know, is the cost of rework that you need to do in order to keep a system functional in the long run. So it can be caused by taking shortcuts because you need to deliver a project or a feature tomorrow. It can be because of problematic code, old code that no one understands anymore, or it can be a system that keeps crashing, causing problems. It could also be the result of changing requirements. For example, so if you have more users in your system than you expected, that's a problem, right? Things are going to be slow. You have performance issues, and the key is to realize that technical debt isn't a negative per se. It's not a bad thing, because the shortcuts that you take to deliver something tomorrow gives you an edge in the competitive landscape. Um, and so balancing is kind of key, right? You don't need to prevent it altogether, but you don't want too much of it. You need to be somewhere in the middle. But balancing isn't the full story. Preventing debt in the first place, where possible, will help you in the long run. And then you map that back into the organizational issues that we talked about, and the role technology plays. So choosing a simple technology over a more complex technology that will still fit the requirements of the problem that you're solving will prevent technical debt, will make you happier in the long run. So simple technology is always better than complex technology if it solves the same problem. Now, if you're interested in learning more about technical debt, a friend of mine, Arjen, he created the technical debt game. The URL is on screen, github.com/Arjen de Ruiter/tech debt game. And it's an actual board game, a card game you can play, which is super fun to realize, okay, this is how I actually balance this. So if you're interested, again, let me know. I'll help you figure out how to play this and what to do with it. One of the last things I want to say before we start wrapping up is the Boy Scout rule. I'm a fan. I'm not a Boy Scout, but I've always liked their kind of mantra or slogan that you need to leave something in a better state that you found it. And this applies to technical debt and solving for those organizational problems as well. Um, so always leave the code you're editing in a little better state than you found it. Always leave the system. Always leave the automation. Always leave the CI/CD pipeline. Always leave everything that you find behind in a better state than you found it. That's kind of the key to making all those small improvements. And that mindset will help you figure out, okay, this is where our actual problems are. This is something I can improve now because it only takes 5 minutes, or this is something that actually requires a project to improve because it's too complex to do in 5 minutes. And that's all another way of saying you need to train yourself and other people around you to recognize the difference between functional and non-functional requirements. Because non-functionals, like complexity, like how easy is it to upgrade, um, how much training do people need to understand this, how easy is it to implement in another team, etc. Those non-functionals are almost always more important than the functional aspect of it. Yes, Kubernetes can do a million things, including auto discovery, or service discovery, auto scaling, etc., etc. But that's almost never more important than the quality, the non-functional aspect of it. Is it easy to upgrade? Is it easy to implement? Is it easy to explain to someone? So quality trumps features every time. Simple, secure, manageable, performance, scalable, maintainable are always more important than functionality. Even if the functionality is there and is exactly what you need, but it's too complex or insecure or not manageable, it's not a good technology. So again, if there's anything I would like you to take home, it's that this quality trumps features every time. They prevent technical debt. They prevent the organizational friction. They will help you make the right choices. And there's another part to this because in a lot of cases, there's a couple of people that understand a piece of technology so well that everyone is dependent on them to solve issues, to explain it to them, everyone is just fully dependent on those people. And so the hero complex is one of those organizational things that I think is what we should prevent, is what we should solve, is what we should figure out how to not have, because we are then not dependent on that select group of people, and that will help you, be more successful with new technology. So hopefully you start recognizing that the organization that you're introducing new technology to, like your employer, your business, whatever, they have to be ready for that technology. And so often that's just not the case. Introducing new technology will not solve much in those cases, even if it takes a little while for the problems to actually surface, like the rework. So I helped you realize that technology is only a very small part of being successful with new technology, and that successful organizations are those that solve their own problems, their own inertia, their own friction on the organizational side without introducing new technology for new technology's sake. But who am I kidding? Of course you need Kubernetes. Kubernetes, all the things. So thank you for listening. I'm going to look at the Slido right now to see if there's any questions. I do believe there's a microphone somewhere. While I have no idea how that works remotely, I'm going to hope that someone in the room will figure it out for me and that I'll hear questions in my ear shortly. But before we go into that, let's look at the Slido for a second. So I have a question from a person called Anonymous. Alongside Kubernetes, what other technologies do you see that have the same problem of really being more organizational rather than technology? So the other big one is cloud. So a couple of years ago, a shadow cloud or a shadow IT was a thing, right? That was because of the organizational problems. The IT department wasn't flexible enough. They wouldn't listen. It would take too long, and so people just go into cloud because it's easier, right? They prevent all of the organizational problems. So cloud definitely is one of those, but in a broader sense, both cloud and Kubernetes are infrastructure related issues because infrastructure is expensive. Often you need capital investment, lots of money, And once you've made a decision, you're kind of stuck with that for a long time, right? So back in the day when I did data centers, if I ordered the wrong servers and I ordered 100 of them, that would be a problem if I made the wrong choice. And so I've had situations where I actually ordered the wrong thing and I ordered 100 of them. And then the organization I ordered them for was stuck in that situation for 5 years because that's the amount of time that they were planning on using it. Like that, everything that needs capital investment in the technology space suffers from this same problem. So Philip has a question, or maybe two questions. First one is, where would you suggest to begin if you know that Kubernetes is going to be overkill, but you do not have internet or can't use the cloud? So Nomad is I think my favorite solution in that sense. If you need the flexibility, because Nomad is super simple. Basically it's a job scheduler. It's cron, but for many different things. So it can do containers like Kubernetes, but it can also do literal cron jobs. It can do VMs. It can do whatever you can execute on a server. That'll be that'll be available inside of Nomad. It's super simple to set up. It's super simple to manage. And so if you need something flexible and simple, Nomad is absolutely my recommendation to at least start your research, right? To start figuring it out. And another part of your question, Philip, do you have any tools or processes for proving to management that they have an org problem rather than a tech problem? Well, the VSM, the value stream mapping, is my preferred way of showing it. So you just literally draw the process, the handovers, the people involved, the stakeholders, the technology, and just whatever you think is a problem, you make red. You literally take a red post-it with a circle around it and say, see, there's your problem. And then you have a discussion on, is it actually a problem? Why is it a problem? How can we solve it? But the value stream mapping is actually very useful in that sense. Let's see, what else do we have? So how do you decide on Kubernetes versus Nomad versus Google Swarms if you know you'll have maybe double, triple number of containers? Well, the scalability isn't the issue. I think all of those, even if you do a simple Docker swarm, if you're going to do a managed Kubernetes cluster, or basically any solution out there will handle triple-digit numbers easily. That's not going to be a problem at all. The limitations are going to be in different areas, right? They're going to be in data protection or performance in storage, or there's going to be limitations in networking, like how can you load balance efficiently across them, right? But the scheduler itself is not going to be a problem. All right. So I have no more questions on my list here. I am going to see if there's any questions with a microphone in the audience. And otherwise, we'll just stare awkwardly at each other for 10 minutes. And I see someone in the back, very faintly.
Can you hear me?
Yes, now I can.
Okay, good. Can Kubernetes be considered as a way to actually solve those issues? Like in my case, organization have some Germany office with support where you need to create the tickets to do whatever with VNet, for example, in Azure. But can Kubernetes be this small world, inside world, where we define rules and don't have to do any ticketing? In that case, I solve the organizational issues with Kubernetes.
No, I think you need to solve the organizational issue, which is ticketing and handovers. And once you decide to solve it, you can use a piece of technology to do so, but you're actually solving the organizational problem, right? Because there's many ways from a technology perspective to solve your issue. Yes, you can use Kubernetes, but yes, you can also use notepad.exe. You can also use Nomad. You can also use a cloud service. You could also use something entirely different that I can think of right now to solve your organizational issue, which is handovers and ticketing systems, right? So again, yes, technology plays a part, But it goes too far to say, okay, Kubernetes solves this problem for me, because it doesn't. Because you need to define new processes, how to work with Kubernetes, for instance, to deploy something from a staging environment to production that will solve your handover. But you still need to create that new process. And yes, Kubernetes can help, but it starts with, okay, this is our problem, handovers, ticketing. This is how we're going to solve it, create a new process that is automated, and we're going to use this and this feature of Kubernetes to do so. Right? So Kubernetes is the third thing, like the third step in this process, not the first step. Does that answer your question?
Yeah, but your solutions, proposed solutions, require you to be of a very high role, I guess, in an organization to solve this. Because here it's most of these decisions are not based on is it good from programming side or from delivery team. It's more politics and money, etc. involved. Who is responsible for what? So yes, it's easy, of course, to say that you need just to solve the to remove the ticketing system, but you cannot do this sometimes. Yeah. But yeah, thank you. I understood your point. Yeah.
Awesome. All right. Any other questions? I don't think so. Well, with that, I want to thank you for taking a look into my home office. I want to thank you for being here for almost an hour. And again, if you have questions, reach out to me. My email address, my Twitter is on screen. Take a photo of it, and I'll gladly help you after this talk and somewhere in a digital space. So thanks so much for being in Oslo. Sorry again, I couldn't be here, and have a good rest of the conference. Bye-bye.